Imagine knowing before a volcano erupts, getting a warning that could save lives and give people time to get to safety. It sounds like something from science fiction, but believe it or not, new research shows that artificial intelligence is making this more possible right now. Hey everyone, make sure to like and subscribe for more amazing science stories. We're on the verge of a major breakthrough in predicting those powerful and unpredictable giants of nature. Let's rewind a bit and look at why predicting volcanic eruptions is so difficult, and how this incredible step forward is happening. Volcanoes are amazing, but they are also very dangerous for the millions of people who live nearby. Right now, the main way scientists try to predict eruptions is by watching for signs like small earthquakes, changes in ground swelling, or gas escaping. Seismic data, information about the shaking of the ground inside the volcano, is one of the most important clues. But there's a big problem. Many volcanoes don't erupt very often. They might be quiet for hundreds or even thousands of years. Because of this, we don't have much past data or monitoring history for many individual volcanoes. This lack of data makes it really hard to train prediction models that are specific to just one volcano. It's like trying to predict a storm based on only a few minutes of weather data. But scientists came up with a brilliant new idea. What if we could learn from many different volcanoes around the world, even those that are very different from each other? That's where they decided to use a type of artificial intelligence called transfer machine learning. The goal was to find universal eruption precursors. These are like hidden signals or patterns in the seismic data that consistently appear before an eruption, no matter which volcano it is or where it's located. To do this, they built a massive data set. They gathered continuous seismic data from 24 different volcanoes all over the world. This included data from 41 major eruptive episodes and covered a combined record length of about 73 years. Think about that. 73 years of ground-shaking information from dozens of volcanoes. They then trained the AI model on this huge dataset. The AI looked at the seismic data in 48-hour windows, analyzing hundreds of different features. It was looking for things like the average shaking intensity in different frequency ranges, like RSAM, MF, HF, and ratios between them, like DSAR, which can tell scientists about what's happening with magma and gas underground. The AI learned to recognize which of these features changed in a statistically significant way in the 48 hours right before an eruption compared to periods when the volcano was quiet. And the results were really exciting. They tested the AI model on volcanoes it had never seen data from during training. This is a tough test, making sure the model can predict eruptions at unobserved volcanoes. The model showed an accuracy that was actually comparable to models trained specifically for those individual volcanoes. It even outperformed traditional methods that just looked at how much the ground was shaking, like basic RSAM triggers. This success points to an important idea called ergodicity in volcanic systems. It basically means that the patterns and signals we see over time at one volcano can be similar to the patterns we see across a large group of volcanoes. This allows the AI to learn from the collective behavior of many volcanoes and apply that knowledge to predict eruptions at individual sites, even those with limited historical data. It's like learning about different types of storms by studying weather patterns across a whole continent, and then using that knowledge to predict a storm in a specific city. This new AI tool isn't meant to replace the experienced scientists who monitor volcanoes every day, but rather to give them a powerful new piece of information. This AI can help support monitoring efforts, especially at observatories that might not have a lot of resources or a long history of eruptions to study. It can help address those data limitations. Of course, this is still new technology, and there are challenges. The models can sometimes produce false alarms, showing a high likelihood of eruption when one doesn't occur. Also, volcanoes have different styles of eruptions, like explosive or effusive, and the current models might be better at predicting some types than others. Sometimes, a volcano might be an outlier, with signals that are very different from those in the training data, leading the AI to miss a prediction. But this research is a really significant step forward. Scientists are already thinking about how to improve these models by adding other types of monitoring data, like gas emissions, thermal changes, or ground deformation. They also want to explore using longer timescales for analysis. By combining the power of AI with the shared seismic language of volcanoes, we are getting much closer to providing earlier and more reliable warnings. This is absolutely vital for helping people prepare and stay safe when these incredible natural forces decide to wake up. This research helps improve our ability to forecast eruptions and reduce the risks associated with volcanic activity. What do you think about using AI for this kind of prediction? Do you find it exciting or a little scary? Let us know your thoughts in the comments below. You can read more about this groundbreaking research in the science journal Nature Communications.